Okay, so sometimes we take data and we convert it to another scale, doing some kind of thing. So it's going to affect the spread. So in some of those cases, we're going to add or subtract a constant to every value. So that will transform the data. So I would definitely write these things in your notes, those three things. So if you add or subtract a number to every data piece, we kind of talked about this last chapter a little bit, but it's going to take the measures of center and add that same amount to every measure of center. So the median will be, if you added 5, the median will be 5 more than whatever it was. The mean will be 5 more than whatever it was. Really, all the 5-number summary values, 5 more than what they were. So it does not change the measures of variability. So like if you have like, this, how spread out the data is. So that's standard deviation, deviation from the mean. IQR is that measure of the middle 50%, the range, the max, minus, and then those are all affected, are not affected. The distance is still the same, right? If your highest number was 10, your lowest number is 2, and you added 5, it should be 15 and 7. The distance is still the same of 8. So the spread doesn't change when you add or subtract a value. However, it does not change the shape either. So the shape will be the same. So let's look at an example here. So soon after the metric system was introduced in Australia, because unlike the United States, they actually use the metric system over there. The actual width of the room was 13 meters. We can examine the distribution. They had to guess. So they guessed, I guess, the width of the room, but the actual was 13. We can examine the distribution of students' errors by defining, so error equals guess minus 13. And so guess minus 13, these are all the different values that they have there, and they have below it has the list of all the mean, the 5-number summary, the IQR, the range, everything there. What shape does the distribution of error have? So if you look at this distribution, how would you describe that? And so it's skewed to the right, and it has 2 distinct peaks. It's the same shape as the original distribution. Find the mean and median of the distribution of the error. So these are not the actual values I picked, but the error where we took the number and subtracted 13 from it. So if you take 16.02 minus 13, so 16.02 was the mean X bar. You can see X bar is the mean there. So we subtract 13 because that's what we did to every data value, and now it's 3.02. And the median would be, again, subtracting 13. So every time we're just subtracting 13 for whatever the numbers are in this particular data. So here's the original data pictured here, but they're saying the new median and the new mean are affected by that subtracting 13. They're 13 smaller. Find the standard deviation. So does that affect, so if you subtract 13 from everything, does that affect the measures of spread at all? So they're still going to be spread out about the same way, right? So it's still 7.14 is the sample standard deviation, and IQR is still 6. So they didn't change at all. Measures of spread are not affecting by adding or subtracting. That would be the actual picture of it. So the error would have the same shape. The spread is the same. You can tell it's almost identical. You just kind of like moved everything 13 left. So what changes are all those measures of like the 5-number summary, the mean, the median, measures of center, that kind of thing. And let's try one. So let's do this one. So all 30 girls in a high school track team ran a 1-mile race. The times were recorded, a dot plot, and all the data is shown there. It was later discovered the person in charge of stopwatch did not start the time until 10 seconds after into the race. So all the times need to be corrected. We need to add 10 seconds to everyone's time, or it'll seem like they ran, they went really fast. So what shape would the distribution of the corrected time have? So really just looking at the shape of the original time. So that's pictured up there. And so then you would write down whatever you think. Go ahead and do that. And so let's just do that. So I think I've got this. So, and you would say it in a sentence probably, their times for the high school, for 30 girls on a high school track team to run a 1 mile race. The distribution would be shaped, and I'm just going to write what shape it would be. It looks like it is skewed to the right. Okay, find the mean and median of the distribution of the corrected time. So the mean and median. So the mean was this, the median was that. So all you're going to do is add 10 units to each one. So you're going to add 10 to that one and add 10 to that one and write those down. The mean times for the high school track team, or those two numbers would add 10. And then find the standard deviation and interquartile range of this distribution. So find the standard deviation and the interquartile range of the distribution of the corrected times. So how does adding a value affect the spread, which are, IQR, standard deviation, so it won't affect it at all. So the IQR, spread, standard deviation would just still be that. Whatever Q3 minus Q1 is, whatever those two are, that would be the answer for that one. Let's just see what those answers are. And there's all the work for it and written in nice sentences there for you. Okay, another way to transform data, which will affect shape and the spread, is called multiplying or dividing by a constant. So this happens lots of times. You're converting centimeters to inches or something like that, where you're just doing some kind of conversion. We oftentimes multiply. And so write this down in your notes. You need to know those three things. When you multiply or divide, you can even think of dividing as multiplying by a fraction. But basically, you're going to have whatever you multiplied by, so you multiply by B, the mean, median, all those things, the measure of center would be multiplied by B. All of the measures of spread, right? Range, IQR, standard deviation, all multiplied by B. So they are affected. And, it does not change the shape of the distribution. So it kind of spreads it out a little bit, but the actual shape, skewed right, skewed left, approximately symmetric, will actually still be intact. So that's interesting. So it won't actually affect the shape if you do that. So here's an example. So because the students have some difficulty with the metric system, it would be helpful to tell them their guesses tended to be about 2 meters too large. Let's convert the error of the data before we report back to them. To convert from meters to feet, we multiply all the error values by 3.28 to convert from meters to feet. So there's the original data values, I believe. So what shape would the resulting distribution of error have? Well, we just talked about it. The shape won't be different. It'll be still skewed right here, maybe bimodal here and something like that. Skewed to the right with two distinct peaks. We could call it two distinct peaks would be a better way to say it. Find the median of the distribution of error. So median will be multiplied by the same value we multiply by. So you take the current median of 2 and multiply by 3.28. And I would show that work. That's always a good idea to show that. Find an IQR. So again, you're going to take the former Q3 was 4, Q2 was -2. You actually could just take the IQR, right? So it's 6. The difference between Q3 minus Q1 is 6, and multiply that by 3.28. Or you take each data value, multiply by 3.28, and then subtract those two numbers. So either way you want to do that, it actually works both ways. This is a picture. You can see the shape is basically the same. It just looks really weird spread out. I actually think the shape is easier to see on the first value in meters than it was when it was kind of spread out with the feet there. But you can see it's more spread out, so that the standard deviation certainly has changed. The range has certainly changed, and clearly the median and mean have as well. Okay, here's an example of one. So all 30 girls, they ran this. Okay, so here's the question. So the athletes wondered what these times would look like if they were given in minutes instead of seconds. Okay, so we took one of the times, each one of the times in seconds, and divided by 60. So we divided by 60. So multiplying or dividing is going to do what to stuff? So what will the shape be? Well, the shape should be the same, right? Shape should not change. So if it's skewed right, still skewed right. The median was 442.85. So you're going to divide that by 60, get an answer. And find the interquartile range of the new so you take the Q3 minus Q1, and you're going to multiply that by, or no, sorry, divide by 60, and you get that one. So that's the work for that. You're dividing each of those by 60, so it does affect all those, except for the shape. The shape is still intact there. Great. That's the second part of lesson 2.1.